thank you very much. You were all on time and all explaining very interesting and different things. And we gave the floor to the next round of speakers.
So we're going to start now the new session on fire impacts and lessons learned. No. Is it? Yes. So we're going to try to keep on time. I'm going to give, I think it's been told, 7 minutes. So I'll stay on a corner, and when there is a minute left, I'll just step forward. So I'm going to introduce Camille Stevens-Rumann from Colorado State University, who's going to talk about fire regeneration, forest regeneration after wildfires. Thank you.
Gracias por invitarme. It is nap time, so why doesn't everybody stand up and shake out for a minute? Es la hora de... Sí, come on, vámonos. Stand up, shake it out. Uno minuto. Come on, no? Okay. Okay, so many of the talks today have been about, what's going on in a fire during the moment, or studying how fires are predicted to burn. And I'm kind of going to talk about what happens after those fires happen. And some of you may be saying, oh, I don't want to learn about that. That doesn't matter to me. Well, it should, and it should because you all live in these wonderful, beautiful areas, and you expect them to recover to a similar type forest or ecosystem that they were before. And as a manager or a practitioner or a firefighter, you also need to know what these areas are going to recover to so that you can prepare for the next fire, right? Every area is just what it's looking like before the next fire. And so really this has to do with the idea of resilience. And I think that's a term that gets thrown around a lot, so I wanted to kind of define what I mean by resilience. So in an undisturbed system, right, you have things accumulating over time. As a practitioner, you may think about this as fuels, right? If you haven't done anything, if there's no disturbance, you have fuels accumulating over time. Perhaps this is vegetation just in general. But when you have a disturbance like a fire, you lose some of those ecosystem properties, or you lose those fuels for a little bit of time. But then they bounce back, right? And the idea of a resilient system is that they bounce back to something similar to what they were before. But in a non-resilient system, they're bouncing back to something very different, right? Perhaps they are now, what was once a forest is now a shrubland or a grassland. And so what influences whether or not an ecosystem is resilient, or whether or not we're seeing tree regeneration? Because I specifically mostly look at forests and whether or not trees are coming back. And there's lots of things that influence it, right? You guys can all think of probably many things that influence what comes back on a site. You can think at the very smallest scale whether or not the soil is right, or you have just the perfect structure for a tree to start growing, a baby tree to start growing back. Elevation may play a really big factor. In the western United States, this is a really big influencer of what's coming back. Perhaps it's aspect. We can have really different effects and different vegetation based on whether or not you're facing south or north, right? And then seed availability. Are there even seeds or trees that are available to provide those seeds that you need for trees to come back at all? And in the western U.S., we generally, in very broad groups, we have these two different large types of forest groups. Kind of those low elevation dry forests, you can think about this as a really open forest type that would have had surface fires but not crown fires historically. On the other end of the spectrum, those high elevation cold wet forests are really dense and generally burned less often but at higher severity. And across this range, we have a really prominent serotinous species, a lot like you guys have. This is lodgepole pine, that kind of spreads into both of those ecosystems potentially, and is really fire adapted to those high severity fires. Another influencing factor is climate, right? In the United States, we're still not on board that climate change is real. all of us, but I'm going to try to sell it still. But we think about climate in a couple different ways. What's the average climate on a site, right? Whether or not it's generally a drier site or it's generally a cooler site. And also what it's looking like post-fire, right? Because maybe it's cooler in general, but those first 3 years after a fire, it's now really hot and dry compared to what it usually is. And that could have a really big impact on how that ecosystem is recovering. And so one of the things that we did was looking at the major factors that influence this across the literature, at least in the Western US. And we found kind of a few really dominant factors. One is that distance to seed source. So how far are you from a living tree? And 29 studies across the Western US found this to be a really important factor. The closer you are to a living tree, the more likely you are to have adequate regeneration. Only 2 studies found this not to be important, and they were in places that either had serotinous species, that lodgepole pine was mostly coming back, or in places where there was really abundant kind of shrub chaparral vegetation, similar to your Mediterranean ecosystems. And so in those cases, maybe it's the vegetation that's more important. Topography, climate, and repeated disturbances, right? You're going to, if you have one fire after another in short succession, or you're impacted by other types of disturbances and then a fire, maybe you're going to be recovering a little bit differently. And so to give you an idea of what this looks like from one of the studies that we did, we looked across 1,500 sites within the Western US to look for tree regeneration. And we compared pre-2000 to post-2000 to try to get at this climate relationship, whether or not tree regeneration was being influenced by climate change. And we found that there's a huge jump in the number of sites that have no regeneration at all. I'm not talking about maybe there's a few trees but not enough. We have about a third of the landscapes have no trees on them at all. So that was really concerning to us. And so this is what we're looking at, right? We need to think about what these ecosystems are becoming, whether they're going to be healthy ecosystems, where we need to worry about putting in trees and where we don't. So we have these kind of landscapes, and I particularly like her because she's looking up at the living trees, right? And across a lot of our landscapes, we're likely going to have those kind of forested ecosystems at higher elevations. But that's not to say that nowhere is having regeneration, right? These are abundant places with abundant regeneration. We had 2 million trees per hectare. You know, just you can't walk and not step on some. I feel bad for stepping on those baby trees. But another thing that we really need to start worrying about more and more is these reburned areas. And in Idaho, in the United States, this is actually a pretty big thing. This is looking at an area that's been burned over 40,000 hectares. It's burned twice in the last 20 years. So that's a really dramatic ecosystem change to then perhaps what it used to be or how big those fires used to be. And that has important meanings for when you have regeneration, right? Could you imagine fighting fire through all of those downed logs and all that regeneration? That means you can't get in there. You can't do anything very effectively. And as a result, that ecosystem looks much different than it did even after the first fire. So we need to understand those effects. So to wrap up, one of the things that I like to say is that we really need to be thinking about having more good fire so that we prevent having less bad fires, because we are not going towards a trajectory that we're going to have less wildfires, right? But in the United States, we suppress 98% of the fires. So those fires that you hear about, those fires that make the news, that's 2% of the fires that burn. So if we can use wildfires to do things that we need to do, like reduce those fuel loads, then we have our preventing those future huge catastrophic fires. And of course, there's lots of other things that you all do as well. Prescribed fire, fuels reductions, anything that increases that heterogeneity and reduces those fuel loads. And then we also do in the United States a lot of planting of those landscapes because we have a prioritization to reforest anything that's unforested or been unforested. So thinking about where we need to plant for future climate rather than the past climate is really important. So with that, I'll take any questions. Back.
So our next speaker is, let me get it, is Pere Pons from Universitat de Girona. Thank you very much.
Thank you, Imma. Good afternoon. I will talk about a topic that has not been discussed so far today, is about what we do with forests once they have burned. And I will start by introducing our research team. It's called PECAT, and this team is located at the University of Girona. Our main research topics are about the biology of invasive species, biological risk assessment, the conservation of animal species, plant-animal interactions, mostly seed dispersion, and also and especially fire ecology. More or less half of the members of the team are involved in fire ecology studies since we started in 1996. And we have done some studies about the dynamics of animal populations after fire, also in bird communities. We also are using cicada species as models for population resistance and dispersion. And the topic I would like to talk today is the effects and how to manage burn forest. So we have seen in different presentations today the fire as a disturbance. These fires can be studied at the temporal or at special scales. But now we have a very common second disturbance that takes place during the first 2 years, usually, after fire. That is the salvage logging, the logging of the burned trees to recoup the economic losses because of fire. And many studies have shown that this salvage logging has severe impacts on the soil because of compactation, erosion, and loss of fertility. Also problems with plant regeneration after salvage logging, decrease in carbon sequestration of the ecosystem, damage to water courses by the machinery. And in general, there can be a loss of biodiversity and a loss of ecosystem services that are provided by this biodiversity. And in the case of Catalonia, the timber from the barn forest is used, especially as biomass,